Hello and welcome! Today we're going to do a past paper question for CIE A-Level Math in October-November 2019. So this question is going to be question 6 from paper 3 variant 3. Now in the beginning of this question, they mentioned that throughout this question the use of a calculator is not permitted. So keep your calculator away. Let's first look at the first part of the question. They say that the complex number with modulus 1 and argument pi over 3 is denoted by W. So express W in the form of x plus iy, where x and y are real and exact. To begin this question, we need to first remember what's the relationship of complex number in Cartesian form and in polar form. In theory, a complex number z can be written as x plus yi, or in polar form it can also be written as r e to the power of I theta, where r here is the modulus and theta here represents the arguments. In general, we know the relationship r cos theta equals to x and r sin theta equals to y. If you don't remember this relationship, you can easily derive this in an argand diagram. Suppose we are given an argand diagram with the real axis and the imaginary axis. A complex number z can essentially be represented as a point in this argand diagram. There are multiple ways to write down the relationship or the relative position of this point z from the origin O. One such way of doing this is using the Cartesian system, which is similar to the way we usually write our coordinate system. In this case, since we can see that the point z is x distance away from the origin along the real axis, so we say that z is equals to x. But at the same time, the point z is also y distance above the origin. In this case, the y distance is along the imaginary axis, hence we write the imaginary number I. This is of course not the only way to represent these points. Instead, what we could do now is we can try to connect a line from the origin to the point z. From here we can see that the direct distance or the direct length going from the origin to the points is given as r, and suppose that this line has an angle from the real axis as theta. The theta here of course actually represent the arguments of the complex number z. From here it is not difficult to see the trigonometry relationship between the r, theta, x and y. If we suppose that we imagine this as a right angle triangle, we can see that x is the length of the adjacent in this triangle, whereas y is the distance or the length of the opposite side of the triangle, whereas r is the hypotenuse of the right angle triangle. Therefore, we can see that x is essentially r cos theta, whereas y is essentially r sin theta. Let's not forget our imaginary number. From here we can actually factor out the r so that we get cos theta plus I sin theta, which from the Euler formula, this is essentially r e to the power of I theta. And from here you can see the relationship of the complex number representation in the Cartesian form and in the polar form. With all these theories in mind, now we come back to this question. Here they say the complex number with modulus 1 and argument pi over 3. So this means that we can write this, our W, as r e to the power of I theta, where our r is the modulus, in this case it is 1, e to the I theta, where theta is the argument, in this case it is the pi divided by 3. But we recall that from Euler formula, we can rewrite this in the form of r cos theta plus I sin theta. And hence we will get r, which is 1, multiplied by cos pi over 3 plus I sin pi over 3. And since pi over 3 is a special angle, therefore you can do this without the help of calculator. You should remember that cos pi over 3 should give you half, and sin pi over 3 should give you sec 3 over 2. And let's not forget our imaginary number I. And that is our final answer. Of course, if you recall the formula from the beginning here, then you could have just directly substitute the modulus 1 and the argument pi over 3 into here. And therefore you can see that x is just 1 cos pi over 3, whereas y is equals to 1 sin pi over 3, which should give you back the exact same answer over here. Now we move on to the next part of the question. Here they say that the complex number 1 plus 2i is denoted by u. The complex number v is such that modulus v equals to 2 modulus u, and argument v is equals to argument u plus pi over 3. So in this part, they say sketch an argand diagram showing the points representing u and v. Now at first glance, you might be tempted to try to find the exact form of v using the polar form, where v is equals to re to the power of I theta. While it is true that you could technically find the modulus of v, since modulus v is equals to 2 times the modulus of u, which can be found since the exact value of u is given, and the argument of v is also given in terms of argument of u, which can also be found based on the exact form. However, we need to remember one of the important points in this question. From the very beginning of the question, they mentioned that throughout this question, the use of a calculator is not permitted. Therefore, in this case, you will not be able to find the exact form of the complex number v, since argument u involves inverse tangent 2, which in general is not something that we know unless you use a calculator. In this case, we should just draw the relative position between v and u based on the given information. Now let us first point out the complex number u first, since the u is already given as 1 plus 2i. So this tells us that it should be 1 unit to the right along the real axis and 2 units above the origin along the imaginary axis. So therefore our u should be something like this. Now that we have found the position of the complex number u, we know that the modulus v is related to the modulus u and argument v is related to the argument u. So let us try to understand what is the meaning of modulus u first. Modulus u can be represented as a circle with the center at the origin. Now why is that the case? Modulus u is talking about the distance from the origin to the u. And this circle is essentially representing every single possible points that are equal distance from the origin to the point on the circle. So every single point on the circle, they will have the same modulus as the u. Now of course, when you write modulus u, you are representing many points around the circle. So how do we actually represent one particular point at u? So this is where the second line comes in, the argument u. The argument u is basically telling us that the point u, if we draw a straight line distance from the origin to the point u, it will make an angle of argument u from the real axis. So now we proceed to find the modulus v. Since we know that modulus v is twice the modulus u, this is telling us that modulus v must be representing a circle of points that has a radius twice as much as u. So the modulus v should be represented as this, the green circle with twice the radius of the yellow circle. So all of the points on this circle will be at a distance twice away from the origin with respect to u. So to represent an actual point of v, we again require the second piece of information, where we can see that argument v equals to argument u plus pi over 3. Now argument in the end, it simply means that the line going from origin to whatever point that we have, it must make this much angle from the real axis. So in this case, we can see that the angle must be the argument of u, which is this angle over here in the diagram, plus pi over 3. Now pi over 3 is roughly 60 degrees, so I think we can roughly estimate that it should be in the second quadrant. Therefore, the argument of v should be somewhere around here, where the angle going from argument u to argument v is pi over 3. Therefore, we can see that the entire argument of v is argument u plus pi over 3. So therefore, the intersection between the modulus v and the argument of v will give us the point that represents the complex number v. And that is our final answer for this question. Now we proceed to look at the final question. They say, explain why v can be expressed as 2uw, where u is given in the previous part, which is 1 plus 2i, and w is also given in the previous part with modulus 1 and argument pi over 3. Hence, find v giving your answer in the form of a plus ib, where a and b are real and exact. So here there are two parts of the question. First of all, we need to first explain why v is equals to 2uw, and after that we need to find the actual value of v in the Cartesian form. Okay, let us focus on the first part. Now in general, if we say that v is equals to 2uw, now if this is true, then in general we say that the modulus of v is the same as the modulus of 2uw, and argument of v must be the same as the argument of 2uw. Now what this means is that if we can show that these two relationships are true, then we can show that v is indeed equals to 2uw. So let's start by showing the modulus. Here we start by finding out what is the modulus of 2uw. So we can actually split them so that it becomes modulus of 2 multiplied by modulus of u multiplied by modulus of w. Now modulus of 2 is essentially just 2. Modulus of u, I'm going to keep it as modulus of u, and you will see the reason why later. The modulus w is given as the as 1. So therefore, this will just give us 2 modulus u. But what is 2 modulus u? If we recall from the information that's given over here, it was told that complex number v is such that modulus v is 2 multiplied by modulus u. So 2 modulus u, 2 modulus u. Therefore, this essentially modulus v. Now what about the second relationship, argument? So we do a similar methods. To find the argument of 2uw, we can split this so that it becomes argument of 2 plus argument of u plus argument of w. Now first we look at what is argument of 2. This is essentially 0. Now why is it 0? Suppose we look at a simple argand diagram on the right here. A complex number of 2 is really just the point of 2 on the real axis. So this is the point for the complex number 2. It doesn't have any imaginary components. So in order to measure the argument, if you recall, argument is the angle between the real axis and the line connecting from the origin to that particular point. And you can see this line is still along the real axis. So since they belong to the same line, there is no angle between them. Essentially, you get 0 degrees. So here I'm going to leave the argument u as it is. What about argument w? So from before, it was already given that the w has an argument of pi over 3. Therefore, we can rewrite this as argument u plus pi over 3. And again, going back to the information that was given before, it was mentioned that argument v equals to argument u plus pi over 3. So we have argument u plus pi over 3, argument u plus pi over 3. Therefore, this tells us that this is indeed equals to argument of v. So now that we have shown for both relationship, modulus v indeed is the modulo of 2uw, argument v is indeed argument of 2uw. Hence, as a conclusion, v is indeed equals to 2uw. So now we proceed to the second part of the question. Hence, find v, giving your answer in the form of a plus ib. So we know that v is 2uw, u is already given as 1 plus 2i, and w, from the previous question in part 1, we have already found the w in the Cartesian form, which is 1 over 2 plus sec 3 over 2i. Now we can just multiply everything in term by term, and we will get 2 here multiplied by half plus sec 3 over 2i plus 2i times half, that will give us I, and then plus 2i times sec 3 over 2i, so that will give us sec 3i squared. So now we are going to simplify everything by multiplying the 2 into the brackets. We will get 1 plus sec 3i plus 2i plus 2 sec 3. Now let's not forget that I squared is negative 1. Finally, group all the terms together, we shall get 1 minus 2 sec 3 plus 2 plus sec 3i. And that is it.